Welcome to Chapter 13, Overloading and Templates Study Guide video. Please hit the like button, leave a comment, and subscribe to the channel. If you are unable to do that, you will need to log in. If you do not have a YouTube account, you can create one free and it takes less than a minute. Let's get into it. Chapter 10 defined and implemented the class clock type. It also showed how you can use the class clock type to represent the time of day in a program. Let us review some of the characteristics of the class clock type. Consider the following statements. Clock type myClock 8:23:34, clock type yourClock 4:5:31. The first statement declares myClock to be an object of type clock type and initializes the member variables hr, min, and sec of myClock to 8, 23, and 34 respectively. The second statement declares yourClock to be an object of type clock type and initializes the member variables hr, min, and sec of yourClock to 4, 5, and 30 respectively. When using class templates, the function definition and client code are compiled together. Recall that the only built-in operations on classes are the assignment operator and the member selection operator. Therefore, other operators cannot be directly applied to class objects by default. However, C++ allows the programmer to extend the definitions of operators such as relational operators, arithmetic operators, the insertion operator for data output, and the extraction operator for data input, so they can be applied to classes. In C++ terminology, this is called operator overloading. Recall how the arithmetic operator / works. If both operands of / are integers, the result is an integer. Otherwise, the result is a floating point number. This means that the / operator has one definition when both operands are integers and another when an operand is a floating point number. Which definition is used depends on the data types of the operand it is used with. Similarly, the stream insertion operator, less than, and the stream extraction operator, greater than, are overloaded. The operator greater than is used as both a stream extraction operator and a right shift operator. The operator less than is used as both a stream insertion operator and a left shift operator. These are examples of operator overloading. Note that the operators less than and greater than have also been overloaded for various data types such as int, double, and string. Equals is an operator that can be overloaded. Other examples of overloaded operators are plus and minus. The results of plus and minus are different for integer arithmetic, floating point arithmetic, and pointer arithmetic. The return type of any function that overloads a relational operator is bool. C++ allows the user to overload most of the operators so that the operators can work effectively in a specific application. It does not allow the user to create new operators. Most of the existing operators can be overloaded to manipulate class objects. Class templates are called parameterized types because based on the parameter type, a specific class is generated. To overload an operator, you must write functions, that is the header and the body, to define what operation the overloaded operator indicates should be performed. The general syntax of the heading of an operator function is return type operator operator symbol formal parameter list. The name of the function that overloads an operator is the reserved word operator followed by the operator to be overloaded. For example, the name of the function to overload the operator greater than or equal to is operator greater than or equal to. The result of an operation is a value. Therefore, the operator function is a value returning function. In C++, operator is a reserved word. Recall that the only built-in operations on classes are assignment and member selection. To use other operators on class objects, they must be explicitly overloaded. Operator overloading provides the same concise expressions for user-defined data types as it does for built-in data types. You cannot create the number of parameters an operator takes. A member function of a class can directly access the member variables of a given object of that class. Sometimes it is necessary for a member function to refer to the object as a whole, rather than the object's individual member variables. How do you refer to the object as a whole, that is, as a single unit, in the definition of the member function, especially when the object is not passed as a parameter? Every object of a class maintains a hidden pointer to itself, and the name of this pointer is this. In C++, this is a reserved word. The pointer this in a member function is available for you to use. When an object invokes a member function, the member function references the pointer this of the object. For example, suppose that test is a class and has a member function called one. When overloading unary operators, if the operator function is a non-member of a class, it has one parameter. A friend function of a class is a non-member function of the class but has access to all of the members, public or non-public, of the class. To make a function be a friend to a class, the reserved word friend precedes the function prototype in the class definition. The word friend appears only in the function prototype in the class definition, not in the definition of the friend function. In other words, friendship is always given by the class, never taken by the function. Classes with member pointer variables should include the copy constructor. The beginning of this chapter stated that certain rules must be followed when you include an operator function in the definition of a class. This section describes these rules. Every object of a class maintains a hidden pointer to itself named this. Most operator functions can be either member functions or non-member functions, that is, friend functions of a class. Suppose that hash represents a binary operator, arithmetic such as plus or relational such as equals, that is to be overloaded for the class rectangle type. This operator can be overloaded as either a member function of the class or as a friend function. We will describe both ways to overload this operator. Overloading the binary operators as member functions. Suppose that hash is overloaded as a member function of the class rectangle type. The name of the function to overload hash for the class rectangle type is operator hash. The general syntax to overload the assignment operator equals for a class is const class name and operator equals const class name, and if an operator function is a member function of a class, then the leftmost operand of that operator must be an object of that class. Therefore, the operator function that overloads the insertion operator less than, or the extraction operator greater than, for a class must be a non-member function of that class. Consider the expression cute less than my rectangle. In this expression, the far left operand of less than, that is count, is an ostreme object, not an object of type rectangle type. Because the far left operand of less than is not an object of type rectangle type, the operator function that overloads the insertion operator for rectangle type must be a non-member function of the class rectangle type. A function template allows you to write a single code segment for a set of related functions. The preceding sections discussed and illustrated how to overload operators. Certain operators must be overloaded as member functions of the class, and some must be overloaded as non-member friend functions. What about the operators that can be overloaded as either member functions or non-member functions? For example, the binary arithmetic operator plus can be overloaded as a member function or a non-member function. If you overload plus as a member function, then the operator plus has direct access to the member variables of one of the objects, and you need to pass only one object as a parameter. On the other hand, if you overload plus as a non-member function, then you must pass both objects as parameters. When both objects are passed as parameters, the code may become somewhat clearer. So, other than following the restrictions on operator overloading, it is a matter of preference whether you overload plus as a member or as a non-member function. In the remainder of this chapter, if we overload an operator as a member function, we will leave it as an exercise for you to overload it as a non-member function. An operator function is one that overloads an operator. The general syntax to overload the stream insertion operator less than is friend ostreme and operator less than ostreme and const class name and overloading the array index, subscript operator brackets. Recall that the function to overload the operator brackets for a class must be a member of the class. Furthermore, because an array can be declared as constant or non-constant, we need to overload the operator brackets to handle both cases. The syntax to declare the operator function operator brackets as a member of a class for non-constant arrays is type and operator brackets int index. The syntax to declare the operator function operator brackets as a member of a class for constant arrays is const type and operator brackets int index const, in which type is the data type of the array elements. An overloaded array index operator function needs constant and non-constant versions. Function overloading. The previous section discussed operator overloading. Operator overloading provides the programmer with the same concise notation for user-defined data types as the operator has for built-in types. The types of parameters used with an operator determine the action to take. Similar to operator overloading, C++ allows the programmer to overload a function name. Chapter 6 introduced function overloading. For easy reference in the following discussion, let us review this concept. Overloading a function refers to having several functions with the same name but different parameters lists. Recall that a class can have more than one constructor, but all constructors of a class have the same name, which is the name of the class. This is an example of overloading a function. Further recall that overloading a function refers to having several functions with the same name but different parameter lists. The parameter list determines which function will execute. For function overloading to work, we must give the definition of each function. The next section teaches you how to overload functions with a single code segment and leave the job of generating code for separate functions for the compiler. Templates. Templates are a very powerful feature of C++. They allow you to write a single code segment for a set of related functions called a function template, and for a set of related classes called a class template. The syntax we use for templates is template declaration, in which type is the name of a data type, built-in or user-defined, and declaration is either a function declaration or a class declaration. In C++, template is a reserved word. The word class in the heading refers to any user-defined type or built-in type. Type is referred to as a formal parameter to the template. Note that in the first line, template, the keyword class can be replaced with the keyword type name. Similar to variables being parameters to functions, types, that is data types, are parameters to templates. In Chapter 6, when we introduced function overloading, the function larger was overloaded to find the larger of two integers, characters, floating point numbers, or strings. To implement the function larger, we need to write 4 function definitions for the data type, one for int, one for char, one for double, and one for string. However, the body of each function is similar. C++ simplifies the process of overloading functions in cases such as this by providing function templates. Like function templates, class templates are used to write a single code segment for a set of related classes. For example, in Chapter 10 we defined a list as an ADT. Our list element type was int. If the list element type changes from int to, say, char, double, or string, we need to write separate classes for each element type. For the most part, the operations on the list and the algorithms to implement those operations remain the same. Using class templates, we can create a generic class list type, and the compiler can generate the appropriate source code for a specific implementation. The conversation constructor is a function that converts its argument to an object of the constructor's class. C++11 Random Number Generator. In Chapter 5 we discussed how to generate random numbers using the functions rand and srand. However, statistically the function rand is not as random as one would like, and its outcome can be predicted. C++11 provides many functions to implement a random number generator. In this section we briefly discuss how to use C++ random number generators utilities in a program. A number of the form a plus ib, in which I squared is -1 and a and b are real numbers, is called a complex number. To use C++11 random number generator functions, we use an engine and a distributor. An engine returns unpredictable, random bits. The chances of obtaining a 0 bit are always the same as the chances of obtaining 1 bit. A distribution returns random numbers whose likelihoods correspond to a specific shape, such as a uniform or normal distribution. Well, that's all for the Chapter 13 study guide. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. If you found this video useful, please hit the like button, leave a comment, and subscribe to the channel. If you are unable to do that, you will need to log in. If you do not have a YouTube account, you can create one free, and it takes less than a minute. Thanks again, and have a wonderful day.